Hello, in this video I'm going to solve question 2 from problem set 1. Let us read the question together first. Is the function capital F defined on the set R, a set of real numbers, by these rules? Capital F of x equals to 2 times x if x is equal to 0 or greater than 0, and it is 3 times x squared if x is negative. Is this function an antiderivative of the function little f defined on R by these rules? 2 if x is greater than or equal to 0, and 6x if x is less than 0. Motivate your answer. Okay, the short answer to this question is no, even though you see that this function is close to be an antiderivative of this function. What do I mean by that? It means that if you see that if x is strictly greater than 0, then capital F of x is equal to 2x. And then, of course, this function is differentiable. And when I differentiate it, it becomes exactly equal to 2. And if x is positive, then little f of x by its definition is also 2. So this means that in this case f prime of x is equal to f of x. Okay, and then if x is negative, then capital F of x is equal to 3x squared, which is a differentiable function, and when I differentiate it, it becomes 6x. But of course, if x is negative, little f of x in this case is equal to 6x again. So you see that again the derivative of capital F of x matches with the value of little f of f at x. But this doesn't mean that capital F of x is an antiderivative, because you see that I have a problem at 0. So in order to understand that, let me try to understand if this function is differentiable at 0. Okay, how should I do that? I will consider two limits coming from the definition of the left limit of the left derivative and right derivative. So I would write limit of capital F of x minus f of 0, because my goal is to check differentiability of capital F at 0, so I'm writing the definition of the derivative for the capital F at 0, but I am interested in calculating the right hand side derivative at 0 for the moment, so I calculate this limit. So if x approaches 0 from the right hand side, f of x, capital F of x follows this rule. But if I ask you what is capital F of 0, this capital F of 0 should be calculated using the first rule again, but this time x is equal to 0, so capital F of 0 is indeed 0. So this becomes the limit. Instead of capital F of x, I put 2x. F of 0 is 0, so I don't write it at all, and then I divide it by x minus 0, which is x, and I calculate this limit, and then you see that this x and this x are cancelled, so the limit becomes 2. Yes. So when the limit is equal to 2, I can say that the derivative of f at 0 from the right hand side, or the right derivative of capital F at 0, is equal to 2. So the capital F is differentiable from the right at 0, and its value is 2. But I also need to calculate the left derivative. So let me check that one. So to do that, I will actually write the same expression for my limit, but this time I send x to 0 from the left hand side. So x goes to 0 from the left hand side. When x goes to 0 from the left hand side, it means that x is negative, so capital F of x follows this rule. But remember, f of 0 is again 0, because when x is equal to 0, capital F of x follows this rule. When I replace x with 0 there, then it is still 0. So this becomes the limit. Instead of f of x, I put 3x squared and minus 0, so I don't write anything, and then the denominator is x, and x approaches 0. So this, if I simplify x's from the numerator and the denominator, I will have the limit of 3x x goes to 0 from the left hand side, which becomes 0. So this tells me that the derivative of the capital F at 0 from the left hand side also exists, but it is equal to 0. And now we realize that the derivative of capital F at 0 from the left is not equal to the derivative of capital F at 0 from the right. So this means that capital F is not differentiable. At 0, at x equals to 0. Okay, so what does this mean? This means that this function is not differentiable on the whole set R, even though it is differentiable everywhere on R except x equals to 0. So this function is not a primitive function for this one on the whole set R. But for example, if you want to, you can define a new function like this. So let me, for example, define capital G of x and write it as 2x if x is strictly greater than 0, and then 3x squared if x is strictly less than 0, and then I define a new function g of x as 2, x is greater than 0, and 6x, x less than 0. So if I have given you these two functions from the beginning, then capital F, capital G, which is defined not on R, but on R minus one single element 0, then this function g of x defined on this set is a primitive function or an antiderivative of little g of x defined on this set. Okay? And by the way, the solution to this problem, you don't need to write this. So the solution to this problem can start from here and then continue on the right column, and this is the solution, because you want to say that no, capital F is not a primitive function for little f. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.